In today's video, we're going to talk about highway drainage and erosion control. In this topic, we're going to talk about highway drainage. About 25% of highway construction dollars are spent for erosion control and drainage structures. The two topics for highway drainage is surface drainage and subsurface drainage. Surface drainage includes water from rain and snow. Some is absorbed into the soil and the rest must be removed from the highway pavement. Subsurface drainage is groundwater that flows underground. After this lecture, students should be able to understand the fundamental design principles for surface drainage facilities, apply the principles of hydrology necessary for drainage design concepts, and explain the methods used to prevent erosion and control sediment from adjacent areas of the pavement. Surface drainage should be designed to effectively intercept all surface and watershed runoff, direct the water to the proper discharge in natural waterways, and this is important because if water is seeped through the cracks in the pavement or in the shoulder areas, this results in serious damages to the roadway. Surface water in rural areas should include sufficient transverse and longitudinal slopes in both pavement and shoulder along the roadway. Surface water in urban highways include longitudinal and transverse slopes as well, but longitudinal slopes are usually designed underground to carry both water surface runoff and groundwater. In transverse slopes, the main objective is to remove the surface water from the pavement surface in the shortest possible time. We can achieve this by crowning the surface of the center of pavement.
Longitudinal channels or ditches are constructed along the sides of the highway to collect surface water that runs off from the pavement surface. This prevents the water from running to the pavement when highway is lower than the ground near it.
In this next section, we're going to be talking about sediment control and erosion control. Sediment control is defined as a practice or device designed to keep eroded soil on a construction site so it does not run off and cause water pollution in a nearby body of water. Erosion control is the prevention of the gradual washing away of soil. One of the devices used in erosion and sediment control is intercepting drains. They're usually located at the top of the cut and prevent erosion from the side slopes. The water is collected and transported in the intercepting drain to a paved spillway that are placed at strategic locations on the side of the cut. The next thing we're going to look at is slope and channel linings. When the cut and the embankment side slopes are steep and located in mountainous areas that are subjected to heavy rain or snow, a common method is to line the slope's surface with riprap or hand-placed rock. They can be either flexible or rigid. Flexible is defined as dense graded bituminous mixtures and rock riprap. Rigid is defined as Portland cement, concrete, and soil cement, more effective but more expensive. So for erosion control, some techniques that are used are sediment basins, check dams, silt fence barriers, brush barriers, diversion dikes, slope drains, and dewatering basins. Pictured below are sediment basins and check dams. For sediment basins, the required when runoff from drainage areas is greater than 3 acres flows across a distributed area. For check dams, they're used to slow the velocity of a concentrated flow of water and are made of local materials such as rocks, logs, straw, or bales. For silt fence, they're usually made out of a fabric, often reinforced with wire mesh. Brush barriers are made of construction spoil material from the construction site, often combined with filter fabric. A diversion dike is an earthen berm that directs water to a sediment basin. Slope drains are used to convey water down a slope, thus avoiding erosion before a permanent drainage facilities are constructed. Dewatering basins are detention areas for the storage of sediment-laden water. In conclusion, drainage occurs due to highway runoff from transverse slopes, longitudinal slopes, and longitudinal channels, also known as ditches. There are major structures and minor structures that help manage this excess water. If a structure has a span larger than 6 meters, it is considered a major structure. If it is smaller than that, then it is a minor structure. This runoff can create issues with washout and sediment movement, especially in construction zones. Some factors to help prevent erosion control are wattles, silt fence, riprap, intercepting drains, slope linings, and channel linings, as well as sedimentation basins, check dams, diversion dikes, brush barriers, slope drains, dewatering basins, and many more. This video showed that roadways are fundamentally designed with different slopes to assist with runoff. Different structures are put into place for this runoff to drain, and there are countless ways to prevent erosion and sediments from getting into the pavement or into the water supply. So some future questions that one might ask are, what is the best way to control runoff on your roadways? Are large storms common? How will you direct runoff to its destination? And what is the best way to prevent erosion in the